So I'm Remi. I'm a developer at Invertase. I've been making a bunch of packages like Riverpod, Freeze, and stuff like those. You may have heard about those before. So here today, Riverpod. Yeah. So here today, we're not going to talk about Riverpod, although we will in an indirect way. I'm going to talk about custom lint. Custom lint is a package to help you write custom lint rules and fixes and maybe refactorings for your applications. So obviously, I suppose a bunch of you here are familiar with Dart already, so I don't necessarily need to explain you what a lint rule is and what's the value in having a lint rule. Instead, it's more about convincing you that writing lint rules is something you likely want to consider in your application, because you likely could automate a bunch of common mistakes in your business, or maybe for your packages if you have some. And so my goal today is to convince you that actually writing a lint is not that hard. And how to do that? Well, let's just do some live coding together. Let's just make a lint rule. Here's someone laughing. Okay, so here for today, we're going to do a simple but fairly common pattern for a lint rule. We have a code generator here. I'm using the Riverpod code generator with the annotation syntax. And so when you have a code generator, it's quite common that you have some annotation that you place on either a class or a function. And then the code generator generates something like $_ and the class name, for example. So here $$ example. And so your annotated class must specify this extends $$ something. But the thing is, you might, for example, forget to specify it, or you could specify one, but maybe specify the wrong one, like maybe something else. That's mistakes you could make, and so we'll try to make a lint rule for this to catch these mistakes and maybe fix it at the same time. So let's get started with this. So first, about the code base we have here. The code base so far is just 2 projects. We have an example and a lint package. So the example is just a main.dart with just what you see here, the generated file here, but we don't really care about it. And a pop spec. Inside the pop spec, we've installed Riverpod and the code generator. And we've also installed custom lint, of course, because we want to showcase it here today. And here we have a custom package we've just made, which is where the source code for our custom lint rules will be. So we're using a path dependency because obviously the code of our lint rule is not published yet on pod. And so the next step is then our lint rule package. So we have here, it's just an empty folder with just a path spec YAML at the moment, with analyzer and custom lint builder. Custom lint builder is a side package to custom lint. It's for when you want to, it's for packages who want to define lints, as opposed to custom lint, which is for perhaps which wants to use custom lint. So okay, let's get started. So first, what we're going to do is we're going to do basically the equivalent of an hello world for a lint rule. We're just going to, inside Dart files, add a warning at the top of the file, which says hello world. Sounds simple enough, right? So for this, in our lint package, the first thing we have to do is, at the source of the lib folder, we have to create a file corresponding to the package name. So the package name here is my custom lint package .dart, because it's a Dart file, of course. In here, we create a function called create plugin, which returns an object called plugin base, which comes from custom lint builder. This object is here, it's just a class, which has a few methods for either defining lints or maybe refactorings, which we call assist in the analyzer world. And so for now, we don't actually define any lints because we haven't written one yet. So let's get started by writing one lint. So for this, I'm going to define a new class, and I'm extending Dart lint rule. Because we want to make a lint rule for down code. So we want to be able to obtain things like the Dart classes inside the files, things like those. If you want to maybe instead make a lint rule for like JSON files, YAML files, you could too, but then you would likely want to just subclass the lint rule itself. So we've made our lint rule. In here we see a few things. We see a lint code. The lint code contains a few things. It contains a name. The name is what you will typically use when you use ignore, so hello world. And the problem message is human readable explanation of what the issue is at the moment. You also have a few extra parameters, like maybe the error severity, to like maybe change the type of errors. So like maybe you want to make a warning, maybe you want to make an error, maybe you want to make an info, something like those. I'm not going to show every parameter. And so then you have this run function in here. This run function is where you will actually perform logic for your lint rule. So that's where you will actually start emitting warnings in here. So a simple hello world that we mentioned before would be, for example, to use those parameters which we have, which will help us emit warnings. And so we could do like reporter and the report for offset. We pass the code we defined before. And since we want to first make a warning at the top of the file for the moment, we'll just specify offset 0 and maybe a random length, like 100 characters, why not? So let's save here. But if I go to my file, I don't quite yet see a warning. That's because applications using custom lint need to have one extra installation step. Just depending on custom lint is not enough. You instead also need to define an analysis option.yaml. Let's do that right now. And so in here, we want to do the following. We want to do analyzer, plugins, and we have to enable custom lint. And while we are at it, we might as well disable analysis on generated files because we don't actually care about warnings on generated files. Okay, so now if I go back again to the main file, we showed up fully. Oh yeah, I forgot one step. We define a warning here, but we obviously, we define a new lint rule, so obviously now we need to add it to the list of lint rule we defined here. So now if I go back to the main once again, we see our warning. Yay, hello world. Oh, beautiful. Obviously, hello world is a bit too simple. We likely want something more complex, like maybe showing the warning on the class name. That would be a lot more interesting than just at the offset 0 on a file. And so fortunately, our Dart lint rule class expose a few utilities to read the content of a Dart file. So for example, I could do something like context.registry. And in here, there are a bunch of methods, which are basically ways to listen to various Dart objects. So like, for example, I could do add variable declaration. This basically listens to every time a new variable is declared in a Dart file. And so in here, we receive a node object, which exposes information about this newly defined variable. So like the variable name, or like whether it's final, whether it's late, what the initializer of the variable is. But obviously, we don't care about variables here. We care about classes. So we could do something similar, but for classes, like add class declaration. And this time we get a class declaration here. So we can now get things like the extend keyword on the class, the name of the class, whether there are implemented classes, mixins, stuff like those. Great. So now we have, with this, we now have classes inside Dart files, and so we could technically just move our warning here, our little hello world, inside those few lines above, inside the listener for Dart classes, and maybe change our warning such that it now prints on the class name. And so a name of the class, if you look at it, node.name, it's a token. And here, where do we see it? We don't, of course. Here, node.name. Oh, sorry, I removed this. Sorry, my bad. So token, yeah. And so we could replace this for offset with for token. And instead, we just directly pass the node.name. Okay, I save. And so now if I go back to the file, we immediately see the changes. And we see our hello world appear on the class name. As you might have realized, we actually get hot reload on our plugins. So like if, for example, I change the code to be something more in line with what we want to implement, like provider extends, the code for our warning immediately updates. So it allows a fast iteration on your writing your lints. But that's not all. We also are able to like do prints in those files. For example, I can do a print in here, hello. And you'll see prints appear in a log file here with the timestamp and the name of the lint rule which defined it. And in this log file, you'll also find other valuable information. Like here we see a VM service URI. This link here is useful for if you want to like debug your programs. You can copy paste this into the attached to process command. If I paste it here, now I have the .debugger, and I can place a breakpoint in here if I wanted to. Well, apparently it doesn't want to. I'll have to give me a second. It's coming back. Okay, and so now if I reattach to the process, okay, so now we get breakpoints. So of course, then you would be able to inspect your variables, see what the class name is, stuff like those. Same thing, if someone were to throw in here, you would see the error message and the stack trace and all inside here. So maybe your users of your lint rule would be able to give you enough information to debug your lint rule. Okay, that's great. Another thing we have here is we're also directly able to maybe ignore the warning. If I add it, like you see, you already see the warning disappear. You don't have to do anything special for it. But yeah, but still the issue is that so far our lint is not doing much because this is technically a valid case. It shouldn't be warning here. Instead, it should be warning for like a case where we forgot to add the extend, like maybe a missing case, or like a case where we did specify an extend, but it's not the right one, so incorrect maybe. So we don't want to warn for this one, but we want to warn for the other two. And so one way we could do this is using this node variable here. As mentioned before, it exposes all the informations about the class defined in a Dart file. So we could do the following logic here. Here I'm obtaining the extends clause on the class. And so basically, if it's null, that means there is no extended class. And so we want, in this case, to warn on the class name. And if there is an extend, then we check that the extend is correctly underscore dollar class name. If it's not, then we warn on the extended class. Let's remove the previous code, and if I save again, now we see that the warning here disappeared. In the case where there is no extend, we do see the warning. And in this case where there is an extend, we now see the warning appear on the extended object. Great, technically our lint is done, technically. But one of the things that would be cool too would be to be able to like add a quick fix to automatically fix the issue for our users. Because technically they can update it themselves, but it would be obviously better. So let's go one step further and do that too. So adding a fix is fairly similar to adding a lint rule. We need to define a new class, myFix, for example, and we extend this time Dart fix with an uppercase. Dart fix works in a way that's quite similar to Dart lint rule. It has this run method with similar parameters. Like we receive this context object, which we saw previously, but we also get a change report. The change reporter this time is not an error. The reporter variable, sorry, is not a change. It's not an error reporter, it's a change reporter instead. Because we don't want to emit warnings, we instead want to emit changes in a Dart file. And we receive extra parameters. We receive the error under the cursor, which we are trying to fix, and the other errors within this file, in case you maybe wanted to fix multiple warnings at the same time. Okay, then we need to once again add the equivalent of listing the lint rules, but for our warning. So we want to list our fixes, my fix. We do that inside the lint rule instead of inside the plugin because a fix is associated with a lint. And so if I save here, obviously I don't see anything quite yet because our run method is not doing anything. So let's do an hello world once again. To do that, we could do maybe a reporter dot create change builder, and we have to specify two parameters. We have to specify a name for our quick fix, so like maybe hello world, and a priority. The priority is about how high the quick fix will show up in the list of quick fixes. So like 0 is likely last, and for now let's just put it first. So we'll use 100 for why not. So if I go here again and I click on the warning, you ignore it, we now see our hello world. But obviously it's not doing anything yet still. So let's go one step further. We likely want to reuse a logic quite similar to what we've done in our lints here, where we want to define the warning, where we want to do the fix depending on whether there is an extends keyword on the class or not. To do changes inside, so we can once again obtain the list of classes inside Dart files, like context.registry.add class declarations. And so now what we could do is maybe create a change builder like before, but with a slightly more interesting message, like maybe extend this specific class instead of just hello world. So if I go back to my file and I click on it here again, we see a bunch of stuff. But for some reason, we seem to see too many quick fixes. We seem to see one quick fix for every class in the file, which is undesired. We should only see the quick fix for what's under the cursor at the moment. That's because we need one extra step. We need to verify that the class here is actually the class under the cursor, under the fix we are trying to fix. We could do this with a simple if condition, which is the following. So this if here is basically doing if the source code of the class is intersecting with the warning under the cursor, then we do this warning, then we show the warning, the quick fix, otherwise we just do nothing. So if I save, and we go back to the main again, we correctly see only the quick fix for the error under the cursor, and we don't see some for the others. And of course, if I go on a class which doesn't have any warning, we don't see anything. Great, so now it's time to actually emit some changes. So to emit changes, we can use the return value of this create change builder function. So change builder, we can then do something like Dart file edit, because we want to edit a Dart file. This Dart file edit gives us a builder object. This builder object has a bunch of methods to interact with Dart files. So you can do something like insert some code inside the file. Maybe you can format parts of the file. Maybe you can add imports. You can do a bunch of stuff. And so in our case, we'll want to reuse a logic similar to the if-else we defined previously for the warning, but instead we want to, instead of emitting warning, we'll want to use this builder to make changes. So we could do the following, like if there is no extend keyword, then we will insert some code right after the class name ends. And what we will insert is an extends keyword with the correctly extended class. And in the case where there is an extend keyword, but it's not the correct one, like it's not the _dollar class name, Then we replace the existing keyword, the existing extended class. So we replace the superclass extended with the actually desired class. So if I save once again, go here, can click on here, and yeah, our quick fix is now working. Yeah, so now we... So as you can see, it took us like maybe 20 minutes to go through together to make a fix with a quick fix. So it's not, obviously I went through it quite fast. So likely if you were to do it if you were to try and write a lint on your own the first time, it would likely take you slightly more. But as I showed before, we have hot reload, we have breakpoints, prints, stuff like those. So in case there is something you need to learn, you can just play around a few times. If there is an error, you'll see it appear in the log file. You can try the different methods and see if something is missing, or maybe play around with all the add something to see if there is an interesting new object useful for your case. So yeah, but it appears that we still have a bit of time. So while we are at it, I figured why not show at the same time how to write simple tests for our lint rules. And so when you think about it, in many ways, this file here is kind of already a test. We have a valid case. And then we have, obviously I fixed this one, a case where we're missing the extend and a case where the extend is incorrect. So for our lint rule, we effectively want to convert this file into a test suite in a way. You could technically think that you could run the analyze command on your project like background custom lint, which is the equivalent of dot analyze but for custom lint. Oops. This gives us the list of warnings in the project. We could technically do something like in the CI, we run the custom lint command and check that the output is the specific output we saw previously. Like we could check that the output of the command is exactly this. That would work. The only downside of this approach is our warnings here kind of pollute the problems tab in your IDE. So you would likely over time forget about fixing issues in here because your lint rule is polluting things. So a way to kind of fix the problem is custom lint comes with a custom way of ignoring warnings. We can do something like expect lints and the code you want to ignore, the code you want to test. So here that's the code of our lint we just defined before. And if you place it in your code here, you can see the warning disappears. But at the same time, if I were to place this expect lint in a place where there is no warning, so like here, for example, where it's working just fine, then now, as opposed to with just an ignore, we have an error on the expect lint line, which basically means that if somehow you were to forget to handle a case, like for example, here I forgot to add an expect lint, that means we have a warning here, so the CI would detect that there is an issue. And at the same time, if our code were to be updated to not emit a warning when it was actually desired to emit a warning, like in this case, say we actually wanted to make a warning here, then we get an error. So in every case, we see a warning or an error, meaning that you can now just run in your CI the .run custom lint command. And if it's passing, if it's returning 0, then that means your link is working just fine. So that's it for basic testing. Of course, you would still be able to run your lints manually using a test, but that's slightly more advanced, so I'm not going to show it here. But there are examples in the custom lint repository if you want to. So that's pretty much it for me. As we saw, we have our reload, breakpoints, and all. I've already went through everything. So if you have maybe any questions, I'll be ready for it.